We're going to look at a method called substitution. Substitution is used to find antiderivatives of functions that arose from the chain rule. Okay, and so here we have our first example, the integral of 4x e to the x squared. What you want to do in these types of problems is look for a part of the integral whose derivative is also sitting within the integrand. Okay, so I see I have x squared up in the exponent. The derivative of x squared is 2x. Now I don't see 2x exactly, I see 4x, but 4x is just 2 times 2x. The derivative that we find can be a constant multiple, or the portion in the integral can be a constant multiple of the derivative of the other portion. So what we'll do is we'll introduce a new variable u, which will be x squared. Okay? So u is equal to x squared. We'll take the derivative of u in order to handle this dx, because we're going to have to substitute dx as well. In order to get dx, we take the derivative, which we usually write as du dx, but we can multiply both sides by dx, so du is 2x, the derivative of x squared, times dx. Now what we do is we go to our integral and place these things appropriately. We have one first substitution, or one first rewriting to do. The 4x I'm going to write as 2 times 2x. And I'm going to group the 2x dx together because 2x dx is equal to du. So now I've highlighted things. I've got the x squared, that's equal to u, 2x dx is equal to du, and I do what the rule says, I substitute. This becomes the integral of 2e to the u du. Now I know how to take the integral of this. The integral of 2e to the u is just 2e to the u, and I don't forget my constant of integration. And now I say, u was equal to x squared, so I substitute u for x squared there. So that's our first example, and you can always check these by taking the derivative of what you have. Our second example is going to involve what happens when we have a definite integral. So here we have the integral from 1 to 4 of the cosine of the square root of x over the square root of x. Now we don't really have much choice here in terms of what we're going to let u be equal to. It's going to be the square root of x, but where do I see its derivative? Well, remember that the derivative of the square root of x involves 1 over the square root of x. So I'm going to let u be equal to that square root of x. Okay, so du is then 1/2 x to the negative 1/2. Remember, this x to the negative 1/2 is precisely 1 over square root of x. Now I need to get dx and the square root of x in the denominator by itself, so I'm going to multiply both sides by 2 to get rid of this 1/2 and put it on the other side. So I have 2 times du is dx over the square root of x. Now why did I group these two together? I grouped them together because up here I've got x dx together as well. So I could group those together as well. Okay. Now, something else that we can do is these limits, the 1 and the 4, are in terms of x. X goes from 1 to 4. So what I need to do, one thing I can do, I'll tell you another way we can do this as well. I can take my variable 1 and replace in my substitution, I said u is equal to the square root of x, replace that x by 1. So u is the square root of 1, which is 1. When x is 4, then u is the square root of 4. The square root of 4 is 2. And again, I'm using u equals the square root of x. So now my integral is not going to go from 1 to 4, but from 1 to 2 when I make this substitution. Okay. So just as a refresher, u was the square root of x, dx over radical x was 2 du, and u goes from 1 to 2. So I'm going to rewrite the integral. I take my dx and radical x in the denominator, group them together. The square root of x up here is going to be the one I'm going to replace with u. And at the same time, I'll replace my limits. So we now are going from 1 to 2. Radical x becomes u, dx over radical x becomes 2 du, And I now need a function whose derivative is 2 times the cosine of u. 2 times the sine of u is the culprit, the one we're looking for, and now we just have to evaluate it from 1 to 2. So we've got 2 times the sine of 2 minus 2 times the sine of 1. An alternative to doing this is you could take this u, replace it by the square root of x, but if you do that, you do not want to change these limits. Instead, you would have 2 times the square root of x here, going from 1 to 4.